Yeah, our next honorable speaker is Srdjan Capkun from ETH Zurich, a good friend, a beloved colleague, and he and his team has been doing research in many different directions. It is not only doing research in one area, and that is what makes it very attractive, that competitive research, fundamental results is one of the kind of goals of his teams in whatever they do. And Srdjan is curious, and he looks into different aspects, and he is a pillar of our system. So I really do not need to introduce him long about his background. He is director of Cybersecurity Center, or co-directors of Cybersecurity Center at ETH Zurich. And today he's going to talk about his new project on sovereign smartphones and share with us his ideas on this interesting project. Srdjan, the stage is yours.
Thank you. So it's always a pleasure to be able to discuss this topic, and thank you for this kind introduction and kind invitation. So this talk is not going to be extremely technical. So it's some sort of a pitch for a new way to design smartphones, and in a way to provide more freedom to users, and at the same time to protect existing ecosystems. And my belief is that trusted computing or trusted execution environments are extremely well suited to do that. And this is joint work with a number of people whose names you can see listed below. So I guess this is not a surprise to anyone. We are locked into essentially ecosystems of two main companies, right? So Google and Apple, Android and iOS, they dominate most of our mobile phones. And even if Android is nominally open source, there are a lot of closed source services that Google maintains and puts into pretty much all the phones, irrespective of which manufacturer builds them, and that many applications rely on. So essentially, even if nominally one could assume that Android is open, and it is actually not really the case. So which means that we are somewhat locked into the ecosystems with gatekeepers, and these gatekeepers can decide what we do with our phones, what we install, how we use our peripherals, for example, which applications are suitable, which are not, and also what kind of performance different applications might have, different kind of access, also simply privacy features that we might have to turn them on or off. So any kind of sensors that we have on the phone are somehow filtered through these systems. And of course, one could say this makes total sense. You know, the operating system is supposed to in some sense mediate access to the hardware, so someone needs to do it. Now, and this brings me to this point, which is that there is a benefit to these systems, right? So there is a benefit to having strong companies that invest a lot of effort into making these ecosystems, so making these operating systems on our phone usable, performant. There are clean APIs for developers. There are great security features. So there is improvement every year to make the code that runs on these phones protected from other applications, to protect the users. There is a rich application ecosystem. So in that sense, these companies are doing a great job of somehow protecting the user. However, this comes at a cost, right? So there are proverbs for this that you can find pretty much in any culture, but you know, one of the safest places on the planet is probably prisons, right? You're fed, you're provided with some shelter from the weather, and you have the walls to protect you against outside threats, but the only thing that you lack is your freedom. So this sort of level of protection comes with a particular type of constraints on your freedom, and these constraints will be obvious through the next slides that I will show. So yeah, so for example, Apple recently rolled out a feature that even if you turn your phone off, they can still locate your phone because some part of the hardware will remain on and will allow this phone to be tracked. Also, there are all kinds of features within Android and within OS that are not well understood. So you often see news articles like these, like Google tracks your movements, whether you like it or not. So there are certain things that you cannot toggle on and off, or even if you can, they're very hard to access and hard to understand for users. Also, these ecosystems are quite aggressive in terms of controlling how applications are deployed and how much they charge for this deployment of applications, payments within these applications, how they are done, and so on. So developers are very often at odds with such practices, and they cannot freely deploy their applications on the system. So even if a developer wants to and the user, they want to deploy a particular piece of software, maybe they are not able to do that unless a certain price is paid. This also becomes very often a political question, right? In different, so there are applications that are removed from these stores, either and the decision making of this and the reasons for this are not perfectly clear. So the way that some sort of censorship is done is also problematic. And if you have gatekeepers, these gatekeepers can kick the applications out and potentially then influence the political processes in countries. The latest thing that we have seen was that Apple, for example, decided to scan the iPhones and to perform scans on the iPhones for sexual abuse images, and this, of course, was highly controversial, right? And so a lot of media coverage resulted in Apple finally deciding to postpone or maybe even, for at least for now, not to turn this feature on. But the issue here is that, of course, if one is running has an iPhone, one will pay a very heavy price of moving to another ecosystem, potentially Android, right? Where one can avoid such scanning, or an alternative would be just to use another type of a phone altogether, right? So there is a lot that has been written on this, most notably by a number of people on the privacy side of things in our community. So I found this article quite a nice read, exactly inspired by this move from Apple. Another example that I want to bring up, because I was involved in the design of this contact tracing system here in Switzerland that ended up being somehow adopted by Apple and Google. So the COVID contact tracing systems that were deployed on the smartphones. There was an entire, if you were not following this, there was an entire political battle in the background happening over access to Bluetooth beacons. So Bluetooth beacons are used in order to discover whether mobile phones are close to each other. However, the content of these beacons is not immediately available to the applications, right? But is instead filtered by the operating systems. And so certain countries were urging Apple and Google to essentially change these privacy rules, because those restrictions were introduced apparently for privacy reasons, right? But then they were restricting possible designs of contact tracing systems and different countries wanted to have more control over these beacons in order to be able to design certain types of contact tracing systems. So these standoffs in terms of are showing that even if governments want to deploy some critical functionality on top of this existing infrastructure, they are faced with decisions by of companies who are gatekeepers and might not simply allow governments to deploy what they like, even if the entire society seems to back that kind of an approach, right? Because in some way, these companies might argue that these techniques might be abused by the governments, right? So this led to an entire discussion over, whose smartphone is this, right? So there's a very nice article by Jim LaRousse, who was one of the people involved in our contact tracing project, who essentially nicely outlines in this article a little bit of a history of this development, right? And how difficult was for us as developers of this contact tracing system, even to get applications scheduled sufficiently frequently in order to use these beacons. So running a service in the background on a phone is subject to all kinds of restrictions of the operating system, and in some sense you can say rightfully so, right? So scheduling of these activities needs to be managed for efficiency reasons. However, then you have to essentially negotiate with these companies to get your services scheduled frequently enough in order to deploy what was thought to be a critical functionality. So I'm not going to go through how these contact tracing applications worked, but they worked by exchanging random numbers, right? Which then were used essentially to detect infections and possible infections, so that people would be quarantined, and applications needed this access in order to implement contact tracing. In the end, the middle solution was found where a part of the functionality was implemented within the operating systems, essentially of Apple and Google, right? And one could think of whether this functionality should have been implemented within the applications which were built by the governments. So I hope that these example cases, and I'm sure that there are many more, convinced you that, and they certainly convinced me while I was sitting at home during COVID times, feeling a little bit desperate and a little bit frustrated with this lack of access to what should be my own device, right? So, and maybe it's the point that probably many other people have already said, is that users should be in control of their phones, right? And then of course, obvious solutions pop to your mind. We should jailbreak our phones. That's also fine, but it's hardly accessible to everyone, right? And it's certainly something that is not very user-friendly, right? Unlocking the bootloader, open source operating systems, that certainly can be done. However, open source operating systems pay, so users of those systems pay a heavy price in terms of the ecosystem and the applications that are available in the Android and iOS markets that most users want to use. And also sideloading, which essentially is again subject to all kinds of restrictions from operating systems. So none of these solutions are actually too user-friendly and can easily result in wide adoption, right? Which is in the end what one would want. So if one, for example, goes for operating systems which do not support, which are more open and do not support Google, for example, Google services, right? Of course, then a lot of functionality would break. Maybe your banking app would not work anymore. Maybe other functionality would not work. So we set out to design essentially a mobile phone, leveraging trusted execution environments or leveraging trusted computing, right? So some form of hardware protection that could solve this problem. But we didn't want to, our idea is not to control what Android or iOS do, right? So we want to build a phone that allows users to protect their own sovereign applications or the OS. So we want the users to be able to install bare metal software on their phones. At the same time, we want the legacy operating systems, as we call them, so iOS and Android, to also run on that phone concurrently, right? And be protected from whatever else the user installs. So building a system where you have a clear domination between the two is certainly it's certainly easy in some way, in the sense that we do have designs that will allow you to have one world dominate the other, right? But what we want is, in some sense, some form of equality, right? So we want a system where these two coexist and cannot interfere with each other. For example, our sovereign world should not be able to inspect the memory of the Android and iOS, and the other way around, right? And inspect or modify and so on. So, and we want the common trusted part on this phone to be as small as possible, right? Because we don't want it also to be, and preferably immutable, right? So something that is simple and small and cannot even be changed that easily, at least, right? So it would be best if there is no need to watch the watcher, right? This trusted layer that we definitely need in any such system. So the TCB needs to be small. So ideally, we want two worlds, right? The sovereign world and this legacy world, right? And we want both worlds that are equally privileged, but of course, the user should be able to assign resources to the worlds, right? This includes also peripherals. There are questions here, right? Maybe one world would be in charge of scheduling, right? Because we do want to leverage the knowledge and the implementation and the maintenance of the legacy OSs. We recognize the value in these ecosystems, right? There is a lot of security, a lot of complexity in the implementation of these legacy OSs. But we do want, so scheduling, for example, of applications could be left to the legacy OS, and this is the assumption under which we are working now. And of course, how many of these sovereign worlds you create, this is not important. You can have many if you like. So clearly, one first thought is, why don't we use the hypervisor, right? So if you use a hypervisor, then somehow all of our problems would go away, right? But this is not so easy, right? So first of all, who will maintain the hypervisor? I mean, the hypervisor is a privileged piece of code that can inspect both worlds, right, and configure and inspect both worlds. And if we decide that Apple and Google will build a hypervisor, then of course we need to again trust Apple and Google with the updates to that hypervisor. Someone needs to make sure that that hypervisor is not doing what it's not supposed to. That hypervisor could restrict what you do in a sovereign world. So in some sense, the whole thing doesn't make any more sense, right? In some sense, there is so much virtualization already in Android, for example, that you don't need to have a hypervisor, right? You could just stay with the existing model. But if not Apple and Google, who would build this hypervisor? So you could maybe think of, let's have an open source foundation that will maintain this hypervisor, and that's maybe even feasible. But the problem is that then iOS and Android would need to be virtualized, which might break some of their security and other models, which we also don't want to break. So we want to provide the guarantees to the legacy OSs that they run in some sense unhindered on this platform. A natural other question is, why not ARM trust zone? Sure, but in at least what ARM trust zone, so in ARM trust zone, the secure state or the secure operating system is strictly more privileged than the normal state. So this of course allows you to manipulate the normal state. So we don't want, again, one of these worlds to dominate the other, right? So ARM trust zone is a good basis for us to build on, but it's not a solution in itself, right? So yeah, so this kind of summarizes it. So secure state strictly more privileged than normal state. The questions of who maintains the secure OS, how do we protect the legacy OS from the secure OS, and so on. However, of course, there are benefits, right? Trusted firmware is trusted, enables context switching, communication, memory isolation between normal and secure state. So it's a good basis for us to build on, and it's one platform on which we could build a sovereign world. And from this moment on, you know, honestly, many of you might have ideas how to build your own sovereign smartphone, as long as you agree with the properties that I just laid out. Our goal was to start a discussion in the community to propose this as a relevant problem first, and then also to work on a solution, on a concrete platform and the design that we believe can solve this in the best way, right? So, and of course there are many related works that designed different kinds of TEs and so on, and one could build on top of them, modify them, and so forth. But we decided to start with ARM and to modify it, and I'll show you a couple of slides on how our design looks like. So what we are going to do is extend the trusted firmware with support for multiple isolated worlds in the normal state, right? And we will use the address space controller for memory and peripheral isolation, right? And our main kind of paradigm is that we want to manage without inspection. I think this is somehow emerging in most trusted execution environments. You want to set up the worlds, but then you do not, there is no inspection that's happening. So your trusted firmware essentially just needs to manage who is allowed to do what without then inspecting its operation. So we started from this, right? So this is essentially the ARM trust zone default state. So we have normal state and secure state. What we will do, we will essentially reduce the secure OS and secure state to the bare minimum. It's not going to really do anything except redirect execution when the system boots. And we will divide the normal state into legacy and sovereign worlds, right? So the secure state is going to split the normal state into legacy and sovereign world, and the trusted and so the secure state has no function here, right? So it's simply there as a part of sort of a legacy design. So the monitor, the trusted firmware will essentially control how these are managed and split, and also will handle different types of interrupts, right? What we decided in our design is that the scheduler will remain within the legacy world, because these companies like Google and Apple spend a lot of time optimizing and scheduling the execution. So we don't want this to be changed, or this functionality, which is a complex functionality, to be moved into a monitor, because then you're building a hypervisor. So instead, we will keep this functionality within the legacy world, and the sovereign world will execute users sovereign apps, or potentially even an entire hypervisor, right? If you want, right? So this is essentially up to you what you want to run here, right? It can be an app, a bare metal app. It can be an OS. It can be a hypervisor if you like. It doesn't really matter. It's your world. Deploy what you want. So of course, there are different details here of how do you handle interrupts, that the legacy world needs to be interrupted even when the sovereign world is running, and of course there are issues. How do how do you manage peripherals and memory? And this is all currently what we are implementing. So I mean, this is just to show you that there is some complexity in designing this particular issue, especially with interrupts. So the considerations, of course, are, you know, what is our common TCB here, right? We want to make it as small as possible. So we have hardware that we trust, boot stages up until the trusted firmware, right? We do need to trust this small piece of code in the secure state, which will then redirect to the normal world. And we will keep the legacy OS responsible for scheduling. And in our current design, this legacy OS could DOS the sovereign world. So this is another issue that we are grappling with. Is the availability one of the properties that we should design for or care about? Yeah, given this, the timer interrupts need to be handled by the legacy world, even if when the sovereign world is running. What this means in terms of security properties, we have to also figure out fully. And what we want is that the user has full control over the hardware, so can configure the address space controller and install sovereign world code. Clearly, one thing that always comes up, and there are always questions regarding this whenever we discuss this, UI issues, right? So the user needs to be aware of which world is running. And of course, you know, I think our community is full of papers that show that indicators and security indicators fail to inform the user properly about which world you're running in, for example, right? So the legacy OS could, for example, pretend to be the sovereign world and trick the user. So you need some sort of a trusted path between these and an indication to the user in which world they are currently running, right? So there will need to be some carefully designed set of either hardware switches or indicators that would help the user navigate this at least the division between the legacy and the sovereign world. And also there is a question of attestation to the user, right? How does the user know that they are installing a proper piece of software in their sovereign world, right? So what I'm showing here below, I don't want it to confuse you. At some point we did a study where we showed to the users Facebook login screens on the phones that had different colors, and guess what? A lot of users just typed in their credentials, even if the color, which somehow should indicate that something is off, was fairly off from what you would expect from, for example, a Facebook login. Yeah. So what is our current status? So we are currently implementing this on QEMU, and we have a number of things are already implemented. We want to get to a certain stage before we release the code, and then we are hoping that other people might also join on this project and help us maybe build this and demonstrate essentially to the community, but also to the phone manufacturers that this is doable, that this can be this can be done without major performance hits, and that this is something that we should do if we want to, in some sense, democratize the use of these devices. So it seems that I ran a bit faster than I maybe should have, but in conclusion, a balance really needs to be found between the services provided by legacy OS companies and the needs of the users to control their phones. And I think this is really a key thing that we that if our community manages to produce designs that achieve that, then also the policymakers will take note of this, and hopefully companies who build phones will also decide to support that kind of feature, and I think that everyone would benefit from this, right? So in the end, the question, why would legacy OS companies support this? Well, that's a very good question. I mean, I'm not sure that they have to fully support this. It would be nice if they would be on board, especially given that the design should not be done in such a way that it harms their security, let's say, models. Of course, the questions of profit and whether this makes sense for them in the long run is a very good one. But I believe that there is a space for phone manufacturers to essentially provide this as a benefit, as a service to the users, because you don't have to choose between functionality and let's say security, right? You can have these two worlds running concurrently on the phone. For a little bit more on this, we wrote a short paper called the Sovereign Smartphone that you can find on Archive, and we are working towards future designs of this. And I know that there are a lot of, I mean, many people will have opinions about this, right? So I'm very happy that if this opens up discussion in our community. So thank you.
So thanks a lot, Srdjan, for sharing your ideas with the crowd today. Is there any question? I see on chat there is some activity, yes, but please speak up. This is a workshop. You can just.
Gordon Mill speaking from Huawei. Thank you, Sergey, for this interesting talk. I would ask, so if you still make the scheduler under the control of Apple and Google, does then your design solve the problem of the location tracking? Because if there is a mandatory part running from Apple or Google to do that, then the location tracking, you cannot avoid this. Or how?
Okay, so I maybe I have not made this point clear. I guess I was under the impression that I'm running a little bit behind time, but our design. So what we are currently working on is that we can dedicate, we can essentially dedicate peripherals to these worlds, right? So you can decide that the primary owner of, let's say, your GPS sensor, right, is a sovereign world. And then the legacy world would essentially need to ask a sovereign world for this information, right? So this the fact that you have this kind of strict separation, and that you can then dedicate peripherals to one or of the two worlds allows you to do this, right? Now, of course, this location issue, if Apple has some hardware built in that tracks you irrespective of what, I think that's a question that we cannot solve using this kind of design. I think this needs to be solved differently, right? I mean, probably on the policy level, right? I mean, it seems like one needs some pressure on Apple to turn this off.
Yeah, thank you.
Okay, there are other questions on chat. Please speak up.
Yeah, so I guess there are questions here, and that's a clear question, right? How does this compare to Realms, right? Is that, if I understood this?
That is exactly the question. Yes.
Yeah. So we are looking into this and trying to see what how we could potentially build this on top of Realms. And what would be the pros and cons. So we are currently evaluating that. Yeah. So that's a good question. I don't have an answer if it would be somehow obvious to do it on Realms, but yeah.
I have another follow-up question. So,
I mean, one thing, sorry to interrupt. I mean, one thing that we need to, because what we are seeing now is that we have to change a lot in the interrupts, and also of course peripherals are complicated, right? And so we are trying to do one at a time, and so we are trying to see if Realms would be able to provide kind of a similar type of an isolation that we want.
Yeah, I was going to add a question here. So how you handle resources which are inherently common? I mean, take as an example a GPIO controller in SOC. So this is usually realized as one piece of IP with several. I mean, that basically controls all the pins that go out of the chip. So, I mean, how would you think about this approach of having some software to arbitrate access to such hardware? That kind of violates the idea, right? To have a common piece of software that you need to trust, or at least you need to keep it as small as possible.
So our idea here is that each peripheral or each resource, let me put it this way, each resource is allocated to one world, if we can do it, right?
Mm-hmm.
So and then the other world essentially has to ask for this access, right? So this we are now essentially going through individual peripherals, seeing for each individual peripheral what we can do on the existing under the existing hardware that we have, right? And then if we manage to cover, you know, half of them, I would be happy, right? Because I think we already made an effort. And then in the, you know, I would be happy if we had a phone in which those peripherals that are performance-wise and also let's say if we manage those peripherals that we technically can dedicate to individual worlds, if we do that, I think we already made a huge step in this game. And then we can think of you know, how do you share, you know, Wi-Fi connections, you know, Wi-Fi or similar kinds of so radios will be particularly nasty, I guess. So you know, sensors like GPS and so on, I mean, those we already have rough ideas how to handle. And but more complex peripherals, of course, we will see if performance will be impacted if there are some other things that would. What I want to also minimize is I don't want the legacy OS to crash as a result of these redirections, right? That's another thing that one needs to think about it, because if one needs to redesign a lot of the legacy OS, then this reduces the chance that this will be deployed. So at the first stage, minimal, if any, interventions into the legacy OS would be ideal. So currently we are working on that, and as soon as we have something, which should be in a couple of months, we will push it out.
Okay. Interesting.
So thank you very much for questions. Any other question? You can just identify yourself and ask questions. It is for free. Support.
And also, if you have ideas, you know, I'm happy when people ask me, how would you do this and that, right? We still don't have this phone in our hands. So I cannot tell you, I cannot give you all the answers, but if you have ideas how to do things, please DM me and you know, send me an email. I'm happy to discuss. We are actively talking to all kinds of partners to see if this can be implemented and deployed. So anyone who wants to contribute, we will be ready in a couple of months to really engage.
Great. So I don't see any other questions.